Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. You are floating now, not in water, not in air, but in something deeper space itself. It's not cold here, not really. It's silent, wrapped in hush. There's no wind, no up or down, only motion without edges, and a gravity that seems to breathe. Ahead, something waits. It doesn't flash, it doesn't move, and yet it pulls. A black hole, though black hardly captures its presence. It is not a color, but a silence, so deep, so absolute, that even light cannot escape it. You are still far away, but you feel the shift already. Time begins to stretch, as if it no longer fits the same rhythm. Out here, clocks tick differently. Imagine a beam of light racing past you. You've seen it before on a sunny day, a gleam on the surface of water. But here, near the edge of a black hole, light does something strange. It bends. It curves inward, like a dancer drawn by music. It spirals. The gravity is so immense that even this fastest thing in the universe, light itself, begins to slow down. You watch. The stars around you begin to stretch. Not literally, not like string, but optically pulled by the warped lens of space. This is gravitational lensing, a gentle distortion of starlight, as if the black hole is holding a magnifying glass to the cosmos and revealing its curved heart. It doesn't tear or scream. It just bends, and so do you. Your sense of time, how long you've been drifting, how long this chapter lasts, becomes soft, rounded, difficult to measure. Black holes do this. They twist time, stretch it like dough. Near them, seconds lengthen, and hour for you might be centuries for someone watching from far away. That's not science fiction. That's relativity, Einstein's idea. It's not a theory anymore, but a measured truth. Gravity doesn't just pull on things, it pulls on time. And near a black hole, the pull is exquisite. As you drift closer, everything that once felt constant begins to yield. Even your own idea of now begins to blur. But you are not falling. Not yet. You are orbiting, softly, slowly. Not in a tight circle, but a wide spiral. Some black holes let you get close. They offer orbits like cosmic benches to sit and watch. This place is called the photon sphere, a ghostly ring where light itself can orbit. Not forever, but long enough for wonder. You float there, not as a person in a suit, but as a mind, a breath, a witness. This chapter is not about danger. It's not about what happens if you fall. Not yet. This is the part where we listen. Where we approach gently, like someone stepping into a cathedral or a forest after fresh snow. You're not looking for answers. You're just looking, and what you see is beautiful. A black hole does not scream. It does not reach for you with claws. It is, instead, a place where the known rules begin to whisper instead of shout. Where the predictable gives way to the poetic. Space curves. Time pauses. Light slows. Your body might not notice, but your mind does. You remember that everything around you, planets, people, even your own heartbeat, follows the same physical laws. But here, near this boundary, those laws start to fold in on themselves. They do not break. They deepen, like a melody that shifts into a lower octave. Still the same tune, just slower, heavier, more profound. You close your eyes, but the vision stays with you. The black hole is no longer a monster. It is a horizon, a place where the map ends and the mystery begins. You can't touch it. You can't cross it. Not yet. But you can feel the invitation. It says, come closer, just a little more. You drift, weightless. Below you, the event horizon. White sea, edge of the black hole. Not a wall, not a surface, but a threshold. Nothing that crosses it comes back. But we are not crossing. Not in this chapter. We are lingering at the edge, like someone standing outside a deep cave. Hand on stone, listening to the echoes. The gravity here is gentle. A whisper, not a roar. It doesn't rush. It waits. And so do you. You wonder, what happened to your reflection here? Would a mirror show your face? Or would the light take too long to bounce back? Would your shadow curve? Would your voice echo at all? These are quiet questions, and there is no rush to answer them. The sky above you still shines. Stars blink. Galaxies spiral. Even here, so close to the edge of gravity's deepest well, the universe continues. Calm, eternal. You are part of it. Not outside, not separate. Just one mind among many floating near the edge of a truth too large to name. Somewhere nearby, a neutron star flickers. Too strange. Heavy, small, bright, but unlike the black hole, it still speaks with light. The black hole speaks with silence. You listen, not with ears, but with attention. And what you hear is something like peace, like being held by something ancient, like drifting close to a truth that doesn't need to explain itself, because black holes don't explain, they invite. They curve the rules gently until you see something new. Not wrong, just deeper, just quieter, just slower. And as you continue to float, as your breath slows with the gravity, as time stretches and folds, you begin to wonder, not what a black hole is, but what it means. What does it mean to slow light? What does it mean to pause time? What does it mean to reach the edge of what you can know and feel not fear, but stillness? You are still hovering here, right at the edge, close enough to feel the stretch of seconds, far enough to remain whole. The chapter does not end with an answer, because black holes do not offer answers. They offer something better. They offer the place where curiosity begins, and as your orbit carries you gently, silently along the curved space around this invisible giant, one quiet question begins to rise from the stillness: if this is just the edge, then what lies inside? You've heard the name 100 times. Black hole. You picture something dark, gaping, maybe spinning, maybe violent. A cosmic vacuum cleaner that devours everything in its path. But that's only part of the story. Tonight, we take the name apart. Not to destroy the mystery, but to shape it into something softer, something clearer, something real. You begin with the word whole. And at once, your mind offers metaphors. A pit, a tunnel, a doorway, a place where something used to be. But this thing in the sky is not empty. It is not a hole in the sense of absence. It is full. Full of gravity. Full of mass. Full of the past. A black hole is not missing. It is compressed. Imagine, for a moment, folding the earth into the size of a marble. The gravity would not disappear. It would intensify. The weight, the mass, the pull, all still there, just in less space. And now imagine a star. Not a small star, but 1, 10, 20 times the size of the sun, burning for billions of years. Bright enough to shape entire solar systems. When its fuel runs out, it cannot hold itself up. Collapses. Not slowly, not politely. It implodes. The core contracts. The outer layers explode. A supernova. But what remains at the center keeps shrinking. Past rock, past gas, past atoms, past even the space between particles. It condenses so completely that it becomes SINGULARA, singularity. Not a thing, not a place you can point to, but a point with no volume and all the mass. It's a place where density becomes infinite, surrounding it, a boundary, the event horizon, the edge beyond which nothing can escape, not even light. And that's where the word black comes in. But black isn't the right color, because a black hole doesn't reflect or emit light in the visible spectrum. It's not darkness, like the space between stars. It's something beyond dark, a place where light enters and simply doesn't come back, not because it vanishes, but because it cannot climb out. Gravity is stronger here than light's desire to travel. The escape velocity, the speed you'd need to leave, exceeds the speed of light. And so, once something crosses the event horizon, it's no longer part of the visible universe. It's not because it's gone, but because it has become unceable. So, black holes are not black. They are invisible, not empty, not absent, not evil, just hidden. Their surfaces do not glow. Their outlines are only known by what they affect. A black hole near a star may pull matter into a swirling disk, an accretion disk, glowing with X-rays and heat, but the hole itself remains silent, still. In this way, it is not even a thing. It is an effect, a consequence, a wound in space, a place where mass has collapsed to the point that it no longer behaves like mass, but like a gravitational trap. You wonder, what would happen if you dropped a feather toward one? Not much at first. The feather would drift, would fall. If nothing else distracted it, no wind, no collisions, it would glide toward the event horizon. Time would stretch as it got closer. For you, watching from afar, the feather would appear to slow down. Closer, slower, redder, dimmer, till it froze, suspended just above the edge. But from the feather's point of view, it would continue, it would fall. It would cross the horizon softly, unknowingly, and never come back. And still, the feather would not be gone. Its mass would be added to the whole. Its information, its essence, may still exist, somewhere, somehow. This question of whether information is destroyed in black holes has haunted physicists for decades. If the universe forgets what it once contained, do the laws of physics still hold? Yes. For another night tonight, you stay with what's certain. Black hole is not a vacuum. It's not a monster. It's not a trapdoor to nowhere. It's memory compressed into gravity. A black hole has no hair, as physicists say. It does not show what made it. Once formed, all you know is its mass, its spin, and its charge. Everything else, the stars, history, its composition, its age, is gone from view. Hidden, perhaps, not erased. In this way, black holes are humble. They do not boast. They do not scream. They simply exist, and they bend the world around them. Light curves near them. Clocks tick differently. GPS satellites on Earth must account for gravitational time dilation, even from our small planet's gravity. Now imagine the curvature near a black hole. Its face folds like cloth, gathered in the palm of unseen weight. You drift through this thought. What if space were not a flat canvas, but a flexible one? What if gravity were not a force, but a shape? Einstein thought. So, he imagined mass bending space-time, and black holes bending it most of all. So a black hole is not just a thing. It is a shape, a place where geometry folds in on itself, a funnel, a curve, a collapse. But more than that, it is a storyteller. Tells of stars that lived and died, of matter drawn together, of time stretched so far it resembles stillness. And what about size? Not all black holes are the same. Some are as small as an atom, but as heavy as a mountain. These are theoretical. Others, stellar black holes, are formed by dying stars. They may weigh a few solar masses. Then come the giants, supermassive black holes, millions, even billions of solar masses, sitting at the centers of galaxies, including our own. Our Milky Way has one. It's called Sagittarius A*. We've never seen it directly, but we've watched stars dance around it at incredible speeds. But their orbits draw an invisible point, revealing a presence we cannot see. And still, you feel it, even from thousands of light years away. So now no more dot. You know a black hole is not a hole, not black, it's not empty. You know it is the memory of a star, compressed into a silence so deep it swallows light. You know it's a place where space curves, time pauses, and certainty wavers. You know it is real, measured, tested, witnessed, and yet still mysterious, still poetic, still a place you cannot touch, only imagine. And as you drift in your thoughts, still hovering at the boundary between the known and the possible, you find yourself asking, if this is what a black hole is, what does it do to time? What happens at the moment time freezes? Time has always been your companion. From your first breath to your last, it walks beside you, invisible, unstoppable. The tick of a clock, the rhythm of your heart, the shadow growing longer on a winter afternoon. But here, near the edge of a black hole, time starts to behave strangely. Imagine floating again. You are gently drifting toward the blackness, not falling, not tumbling, just moving with stillness. The black hole is in front of you, massive, silent. Its pool is invisible, but it cradles your path like a hand cupping water. At first, everything feels normal. Your thoughts come as usual. Your body, imagined here like a phantom in a dream, feels whole. But as you approach the event horizon, the boundary beyond which nothing escapes, something happens to your sense of rhythm. Time begins to stretch. From your perspective, nothing changes. You feel the same, but if someone were watching you from far away, floating far beyond the black hole's influence, they would see something different. They would see you, slow. Each second of your time begins to take longer for them to observe. Your motions appear delayed, as though playing through molasses. Your heartbeat, your gestures, even your blinking becomes drawn out. This is not an illusion. It is real. Einstein's general theory of relativity tells us that time bends near gravity. It's not just a little, profoundly. The stronger the gravitational field, the more time stretches. And near a black hole, especially near the event horizon, the stretching becomes so extreme that, from an outside perspective, you appear to freeze. This is called gravitational time dilation. You're not frozen, of course. You're still moving, still thinking, but your time is not their time. For someone watching, your last second before crossing the horizon takes longer and longer to complete. Minutes, hours, years, centuries. Eventually, it takes forever. They never see you cross the boundary. From their view, you asymptotically approach the event horizon, but never quite fall in. You become a statue, a ghost suspended on the edge of reality. But from your point of view, you cross it easily. You don't even notice. The moment passes like any other. You drift past the invisible line, unaware that the universe has lost sight of you. There is no flash, no jerk, no sudden feeling, steady and soft, toward the singularity within. And now, you are inside, but outside, time ticks on. Millions of years may pass in the universe. Civilizations rise and fall. Stars are born and die. Galaxies collide, rearranging their shapes. But your last second from the outside still appears to hover at the brink, forever, unfalen. It is as though time splits into two branches, one for the observer, one for the traveler. Two clocks, once synchronized, now part ways forever. You hold this image in your mind, a friend watching from far away, eyes wide, waiting, hoping, but never seeing you vanish. You remain frozen on the edge of the black hole, a final glimpse stretched across eternity, and inside, you are gone, to where no one knows for sure. But what we know is this: the event Horizon is a boundary not just of space, but of time. Outside it, events unfold in sequence: past, present, future. Inside it, time collapses inward. Everything falls. Everything leads toward the singularity. And so, in a way, falling into a black hole is falling into time itself, into the deepest part of the clock. Let's linger here. Imagine a clock strapped to your wrist, a beautiful thing, gold-rimmed, softly ticking. Okay? Now imagine walking toward the event horizon with it. To you, the seconds tick normally a bit. Someone were watching from outside. They would see the hands of your watch move slower and slower until they nearly stop. And now imagine a beam of light. It shoots upward from your watch toward your observer. Each beam must climb against gravity. And the deeper you go, the harder to climb. The light stretches. Its frequency lowers. T becomes redder and redder until it's no longer visible. That's called gravitational. REDSHIFT. Another whisper of time's distortion. So now the light from your watch never reaches them. Not clearly. It becomes fainter, slower, deeper in tone, until it fades completely. Your clock still ticks, but no one can read it. Time, in a black hole's embrace, becomes private. Only you experience it, and for the universe. It's as if you've vanished in slow motion, stretched across centuries, smeared across the sky near the black hole's edge. But of course, this only applies if someone is watching. What if you're alone? No observers, no cameras, no audience. Then, the idea of time freezing loses its meaning. Because time, like so many things, is relational. It only stretches compared to something else. Without a second clock, without a second viewpoint, there is no slowness, no dilation, no pause, just being, and in that being, you continue your fall, falling toward the singularity. Inside the event horizon, all paths lead inward, not just through space, but through time. You cannot escape, not because you are trapped in a cage, but because every possible future takes. Get closer to the center. It's not a choice. It's the shape of the world now. Imagine a mountain range, but upside down, an invisible funnel. No matter where you step, the slope carries you deeper. You might think you're standing still, but the very shape of time guides you toward the core, and the singularity waits. A point where all our understanding breaks down, where density becomes infinite, where our equations spin into nonsense. Not because they're wrong, but because they were never meant to see so deeply here. Time ends, or begins, or becomes something else. We don't know. Our physics ends at the edge of this thought. Some believe the singularity is real, a place of pure gravity, where all mass is compressed into a single point. Others think it is a sign, a boundary where new physics must emerge, a clue that our picture of space-time is incomplete. And still others imagine that, deep inside, space may open again, that another universe may bud from the collapse. That time, folded in one direction, may bloom in another. But that is not tonight's journey. Tonight, you are still falling, still slow, still stretched. Your clock ticks on, but no one can hear it. The world has left you behind. Or perhaps you have left the world, and somewhere, it's far away, a friend still looks toward the black hole, still hoping to see you move, still holding their breath as your final wave, your last signal, stretches endlessly into red dot. You are frozen in their eyes, but not in your own. You are warm. You are moving. You are becoming something new. You are not stopped. You are not lost. You are not forgotten. You are simply in a place where time behaves differently, and as you drift toward the center, toward the singularity that no one can see, you begin to wonder if time can freeze. What happens to everything time once held? Where does memory go? Memory go. You begin this chapter with warmth, not gravity, not time, but light. Because before a black hole was a black hole, it was a star. It's brilliant, fiery sun that once carved light into the darkness. And tonight, you step backward before the freezing clocks in bending space to meet that star. You close your eyes, you feel its heat, not on your skin, but in your thoughts. A pressure, ancient and steady. The pressure of fusion, of hydrogen becoming helium, deep in the belly of a glowing world. Stars do not shine because they burn. They shine because they fuse atoms, crushed together so tightly they become something new. And in that fusion, light is born. Photons, tiny messengers launched into space, bouncing for thousands of years through the layers of the star, before finally escaping, leaping outward across the vacuum. This light touched planets, heated ice, lit up moons, and for millions, even billions of years, the star endured, balanced, a quiet tug-of-war between gravity pulling in and fusion pushing out. You imagine that balance now, a harmony of force. Gravity wants to collapse, star to draw it inward, but fusion resists, creating enough energy to hold the weight at bay. The star breathes in slow pulses, flares with storms, and settles into calm. It is alive in its own way. It is stable, but not forever. Because fuel runs out, hydrogen becomes helium. Helium becomes heavier elements, carbon, oxygen, and deeper still, into the iron heart of the star. But fusion has limits. It cannot continue forever. Iron, once made, does not yield energy through fusion. It costs energy, and when a star's core fills with iron, it faces a decision it cannot avoid. Gravity wins in a moment that takes less than a second. The core begins to collapse. It's not a fall, it's an implosion. The mass at the center folds inward, compressing faster than you can imagine. Densities rise, temperatures skyrocket. Protons and electrons are crushed into neutrons. Neutrinos flood outward in a burst of invisible light, and then a rebound. The outer layers of the star slam into the collapsing core and bounce, not gently, violently. The result is a supernova, one of the most powerful events in the universe. It's a shockwave that blasts material into space at 1/10 the speed of light. For a few brief weeks, the star outshines entire galaxies. But this is not the chapter of its glory. This is the chapter of what comes after, because not all of the star is thrown away. The core remains, and if the star was massive enough, more than 3 times the mass of our sun, the pressure becomes unstoppable. Even the neutrons cannot resist. No known force can hold it up, so it collapses further and further until all mass is crushed into a single point, something like it. A black hole is born. But that phrase is not quite right. It was not born in the way we imagine new life. It was folded inward, created by subtraction. A star died, became smaller than memory, and yet it is not nothing. It is still mass, still weight, still gravity. The star may be gone, but its pull remains, and so does its story, even if we cannot read it anymore. You imagine a whisper now, a sigh that follows the explosion. It is not sound, is not heat. It is a gravitational presence, quiet, immovable. The black hole waits. It no longer shines. It no longer burns. But in its silence, it reshapes the space around it. Its planets that once orbited the star may continue if they survive the blast. They circle the black hole now, not knowing the light is gone. That's the strange truth. Black hole can have the same mass as the star it came from, so the gravity it exerts on distant objects is the same. The difference is in the center. Where there once was light, there is now darkness. But darkness is not death. It is transformation. The star that became a whisper did not vanish. It changed. Its light is gone, but its influence remains. It bends light, It bends time. It bends your imagination. You wonder how many of these quiet ghosts filled the sky. We cannot count them easily. Most black holes are invisible, known only by the motion of things around them. A star that dances in a strange ellipse, cloud that heats up near an unseen center, an X-ray flare that hints at something more. These are footprints, and they lead to the collapsed, hearts of ancient stars. Even our own galaxy has them. Thousands, perhaps millions, some alone, some in binary systems, where a star and a black hole circle one another, and where the black hole slowly pulls matter from its partner. That matter forms a glowing disk, spins, it heats, it shines. So black holes do have light, but it does not come from within. It comes from the struggle around them, from stars trying to hold, from gas resisting the fall, from time pushing back against gravity. But always, the center is quiet. You return to that image of a star, massive and bright, living for millions of years, and then collapsing into a single, silent point. It is humbling. It is poetic. It is also true. The universe is not sentimental. It allows things to end. It allows them to transform, but it never wastes them. Black hole is not a grave. It is a continuation, a new phase in the life of matter, a place where energy, light, and memory are gathered together under gravity's cloak. And you, floating in this stream of stars and collapse, begin to see the beauty in endings, because they are not voids, they are shapes, they are echoes of what came before. And so, the black hole, once a star, becomes a whisper of time, of gravity, of mass without form. It tells you a secret. Nothing that shines is lost, only it's changed. And as you listen to that whisper, you begin to wonder, if a star can become a black hole, can a black hole remember the light it once held? At first, you imagine space as still a quiet stage upon which matter performs its celestial ballet. But in the presence of a spinning black hole, the stage itself begins to move. Dance is not on the stage. Dance is the stage. You float toward a rotating black hole. Its name, in scientific terms, is Kerr. But in your quiet mind, it feels more like a whirlpool of night. Here, gravity doesn't just pull, it turns, it twists. It drags space like fingers, pulling silk through water. This is frame dragging, and it is not just a theory. It is something the fabric of reality does. Under pressure, under spin, under the weight of collapsed stars, a black hole spins because the star it came from spun. Just as an ice skater twirls faster when pulling in their arms, a collapsing star preserves angular momentum, only now it spins impossibly fast, spins with such precision, such speed, that it warps not just the matter around it, but time itself. Imagine being near it. You move forward, but space is moving sideways. You try to fall inward, but the whole of reality begins to tilt. Even light must obey the spin. It spirals inward, drawn not just by gravity, but by the twisting of the very stage it travels. On dot, you reach the ergosphere. It is not the event horizon. It sits just outside it, swollen region of bent space where no object can remain still. It's not because it falls, but because space itself is spinning so fast that everything is forced to follow. Even if you tried to hover, even if you had rockets stronger than stars, you would still be carried around by the slow hurricane of speed. Acremy. Inside the ergosphere, something strange becomes possible. You could, in theory, extract energy if you dropped a particle in and split it in just the right way, half falling in, half escaping. The escaping piece could carry away more energy than the whole had before. The black hole would lose some of its spin. This is the Penrose process. It's not science fiction. It's science, whispered by mathematics, written in the curves of Einstein's equations. And so, you drift. Mentally, into that region, half light, half shadow, where possibility feels heavier than certainty. You are watching the universe churn inward and around, as if a storm were made of space and not air. You are not afraid. You are curious. You are quiet. Even this giant, dark, dense, devouring is not violent in the ways you expect. It is not loud. It is not bright. Its fury is silent. Spin is steady. And yet, within it are forces beyond comprehension. A storm so deep it doesn't rustle leaves, but bends reality. The faster a black hole spins, the more dramatic its ergosphere becomes. In extreme cases, it bulges wide, a swollen band of spinning space that draws everything into orbit before finally letting go or pulling inward forever. Inside the horizon, K still, the equations say the singularity itself is no longer a point. It is a ring of infinite density, but with a shape, a motion. And this ring, they say, might even open strange doors. A spinning singularity, some suggest, could allow passage, not to another place, but to another time. A hypothetical path through the hole, a bridge, a tunnel, a wormhole. But these are fragile things, theorized, imagined, woven more of mathematics than matter. Still, they sit in your mind like a soft question. What if you breathe again, slowly? Your mind doesn't race. It drifts. It spirals. It moves with the spin of the unseen giant. Everything you know about force, about pressure, is different here. Here, gravity does not merely pull down. It dances. It sways. It drags you sideways through time. You understand now why light curves, not just because of gravity, but because the floor beneath it is turning. Even photons, those fastest things, cannot outpace the twists. You reflect on our Earth, spinning gently once every 24 hours. You remember how its spin shapes wind, weather, the tides in your bloodstream. And you realize, spin is not a side detail. It is a source of power, change, of balance. What if our sun, too, left behind a curved black hole one day? Would its memory be a spin? Would its rhythm be preserved in the dragging of space? The thought is neither terrifying nor comforting, just deep. It's real dot here. In this chapter, you are not falling into a black hole. You are floating near it. Not too close, not too far. Close enough to feel the slow pull of its motion on your imagination. Close enough to see how the universe, even at its most extreme, still moves with elegance. You learn that not all power is explosive. Some power is patient. Some force is not loud, but persistent, like a tide, like breath, like the spin of a dead star still echoing through space millions of years later. And so, Cass, you gently leave this orbiting thought. You carry with you the image of motion, not movement, but motion itself. The world turning, the stars turning, gravity turning, pulling not only down, but around. You feel that spin in your bones. It's not fast, but certain. It's not dizzying, but deliberate. And you drift quietly, your thoughts slowly settling to the next question. Not what a black hole does, but what it forgets. Or perhaps what it remembers, because even in the calm of its rotation, something remains, a trace, a whisper, a memory waiting just beyond the veil. You've fallen before into a bed, into dreams, into the arms of someone you love, but fallen into a black hole. It is not falling the way you know it. It is something slower, deeper, stranger, something that bends the definition of motion itself. You imagine standing just outside a black hole's event horizon, the boundary where space no longer returns. The stars still shine behind you. The light from your home planet still sparkles across the infinite sea of black. You breathe in, nothing happens. You are still whole, still here, but time begins to shift around you. It is not that you are falling as much as the space beneath your feet is slipping, stretching, warping. The closer you get, the more this feeling sharpens not fear, not even speed, but a strange kind of surrender. Not forced, not dramatic. Quiet, almost thoughtful. You might expect to plunge, to tumble, to spin, but that isn't how black holes work. Gravity here doesn't pull you like a hand, reshapes the map you walk on. Imagine stepping onto a blanket that slowly wraps itself around you, tighter and tighter, until you are not moving across the surface at all but into it. This is the elegance of curved space. It invites you in without force. It folds you gently toward the center, and you do not resist. From far away, someone watching you may be a distant explorer, or a curious probe would never see you cross the line. From their view, you slow down. As you approach, time stretches like a film slowed to a still. Your final moment just outside the event horizon lasts forever in their sky. You seem frozen there, suspended in hesitation. But inside your own mind, time flows as usual. Your heart still beats. Your thoughts still hum. You drift closer, unaware that from the outside, you've already vanished. This is the great paradox of falling into a black hole. From the outside, it looks like you never make it. From the inside, you already have. And what happens next? The light around you begins to curve. It's not in a dramatic whirl, but like fog wrapping itself around a lamp. Stars bend out of place. The sky behind you becomes a shrinking circle of brightness, and in every other direction, black. Not the black of a cave or the back of closed eyes. Okay? This black pulses with mass, not color. Okay? It's the absence of a return path, the closing of the universe behind you. You might begin to stretch not painfully, not grotesquely, but in the physics sense. Gravity at your head is slightly different than gravity at your feet. This is called tidal force. Near most black holes, it's too small to notice. But near the smaller ones, it becomes stronger. The universe starts to elongate, youpling your atoms into a line. Some scientists call it spaghettification. Word so silly, it barely seems fit for the grandeur of where you are. But there's truth in it. You are drawn thin, your molecules rearranged, not by violence, but by the simple difference in how space pulls on each part of you. And yet, you do not feel pain. You feel awe. You feel surrender. You feel the way a leaf might feel when caught in a still, deep river. There is no wind, it's no sound, only gravity, whispering with infinite calm. Come closer. There are no guides here, no signs, no instructions. No one knows what happens at the center of a black hole. We call it a singularity, a point of infinite density, where all known physics dissolves into silence. But that word, singularity, is just a placeholder, sigh of science, admitting we do not know. Not yet. Perhaps space ends there. Okay, perhaps it begins again. Or perhaps in that final moment, you become part of something else, something stored, remembered, reconfigured. Some theories say you may never reach the singularity. That quantum effects, small and strange, may dissolve you first. That information, every atom, every memory may be encoded somehow on the event horizon itself. That falling in is not destruction, but transformation. And so, in this fall without falling, you become a question, a trace, a ripple on the fabric of reality. This journey, though slow and soft, changes everything we know about the universe. Because black holes are not just places of mystery, they are the places where everything we understand begins to unravel. They challenge our definitions of time. They defy our concept of space. They hold mass, yet shrink to a point. They hide, yet radiate whispers. They erase, yet may remember. You float now, deeper than light. Not falling anymore, just ... continuing. You no longer know what direction means, or distance. There is only curvature, compression, curiosity. And yet, your story, your journey is not over. Because even here, even now, the laws of the universe, whispered gently, they do not stop, simply become quieter. Your fall may end, but the question of what happens next lingers. And somewhere, far beyond, scientists watch. They listen to echoes. They map the edges. Okay? They dream of equations that might complete the story. In one voice, gentle, clever, determined ones, whispered that black holes aren't the end, that perhaps they're where a new kind of understanding begins. That voice was Stephen Hawking's, and the next chapter belongs to him. To him. You sit in the darkness now, deeper than before. Not in fear, but in quiet presence. The kind of presence that comes when you stare at the stars and realize they might be staring back. The space around you is soft, vast, unfolding like slow music, and in this soft dark, a question begins to hum. Not loud, not urgent, steady like a heartbeat beneath everything. What happens to the story of a thing once it falls into a black hole, a spoon, a sigh, star? The universe, it seems, remembers everything. You can feel that in your own body, every scar, every wrinkle, every memory that flickers behind your eyes when you're half asleep. You are not just made of atoms, you are made of what happened to those atoms. You are not just matter, you are memory wrapped in motion. But what if memory falls into a black hole? Let's begin with something small, a particle. It drifts in the vacuum, light enough to be carried by a thought. It has a spin, a position, an energy, a tiny, complete signature. It approaches the event horizon, that soft boundary around a black hole where time starts to stretch like honey and space folds inward like cloth. The particle disappears. From your perspective on the outside, vanishes. But physics doesn't like vanishing. The laws that govern your world, your body, your universe are built on a promise that information, once written into the cosmos, is never erased, rearranged, yes, scattered, absolutely, but deleted. That's not supposed to happen. So, where did the information go? For decades, this question whispered at the edges of cosmology. Some physicists tried to ignore it. Others argued about it through chalk dust and radio interviews. Some believed the information must be lost, that black holes are the ultimate forgetting machines, like cosmic shredders, tearing up the blueprints of everything they consume. But others, they weren't so sure. You see, when you burn a book, the words seem to vanish. But if you could gather every ash particle, every puff of smoke, every photon of heat, you could in theory reconstruct the story. The information is scrambled, scattered, but not gone. Fire transforms, doesn't destroy. Could the same be true for black holes? Stephen Hawking, the gentle genius in the wheelchair with the robot voice, asked that very question. He proposed that black holes emit something, a breath, so faint it barely exists. We call it Hawking radiation. It's not a scream, it's not a flash, just a whisper of energy leaking out over eons. A black hole, it turns out, is not completely silent. It evaporates, very slowly. It's like a snowflake under moonlight. And in that evaporation, Hawking wondered, could the information be encoded? Imagine a melody being played on an instrument made of gravity. The notes are faint. The air is thin. But maybe, just maybe, each note carries a trace of what fell, in a hint of a planet, a poem, a beam of starlight. If that's true, then black holes are not vaults. They are librarians, but the shelves are hidden. The books are melted, and the ink is written in a language we don't yet speak. Still, this idea gives hope, because if the universe remembers, then you are never truly lost. Even if every atom of your body were to fall into a black hole, even if the world forgot your name, the universe wouldn't. Your imprint would ripple at the edge of gravity, coated in the quiet hum of Hawking's whisper. Now, picture the edge of a black hole, the event horizon. It's not a wall, it's a surface of transition. It's a fall past. It is to drift beyond return. But some scientists suggest that the information doesn't fall past it at all. They believe it stays there etched into the horizon itself, like data burned onto a cosmic disk. This idea is called the holographic principle. It says that everything inside the black hole, all the complex, light, multidimensional matter and motion might actually be described by a simpler two-dimensional surface, like a 3D world encoded on a flat screen, like a movie playing on the walls of space. It's strange, isn't it? To imagine your whole being, your past, your possibilities, it's all flattened, all woven into the shimmer of an invisible curtain. But perhaps strangeness is truth in this part of the universe, in this view. The black hole doesn't destroy this story, it stores it, not as a picture, not as a sound, but as a pattern of ripples, curves, and shifts sitting in the fabric of space. Now you breathe again, slowly, a little deeper. You begin to see the black hole, not as a mouth, but as a memory palace. Everything that enters becomes part of its structure, not visible, not accessible, but present. Each particle adds a note to its quiet song. Each galaxy adds a verse to its silent poem. So what does this mean for you? It means that nothing is ever wasted. That every gesture, every motion, every whisper you've ever made still exists somewhere. Even if it disappears from your life, your mind, your mirror, it might live on, etched into gravity, humming beneath time. You too are made of information. Your DNA is a code. Your brain is a network. Your choices ripple outward in patterns. You're not just a person, you're a process, stream of data, moving through time, a fingerprint that never quite fades. So when you wonder, what's the point? When you fear being forgotten, remember this: the universe records. In light, in gravity, in shadow, in black holes, strange and silent as they are, might be its deepest notebooks, not to erase, but to remember. The math isn't settled. The theories clash. Some scientists believe the information must be lost, irretrievable, fragmented, beyond recognition. Others believe it hides in correlations, in the soft symmetries of space. And some suggest that we're asking the wrong question, that maybe the way we think about information, linear, logical, labeled is too small. That memory, in the language of the cosmos, is not about exact replication, but resonance. Maybe what matters isn't whether the universe stores everything. Maybe it's that the echo of a thing survives. It's not the object, but the impact. Not the particle, but the pull it left behind. You rest in that thought, quiet, weightless, suspended in possibility. And somewhere out there, a black hole spins, not in chaos, not in violence, but in containment. A stillness so deep it curves space around it. You will never see inside. But maybe you don't need to. Maybe it's enough to know that even the darkest places are keeping something. That even the things we think are gone are held at. And if black holes are the keepers of lost memory, then perhaps they are not the end of stories, but their resting place, like a library with no doors, like a whisper no one can hear, but still it echoes. And now you listen, because in the next chapter, a voice begins to rise from the quiet. A voice that does not shout, but glows, faint, mathematical, persistent. It is the whisper of Hawking's light, and it changes everything, everything. You float, still. The void around you is not silent, but hushed. It hums in frequencies too low for the ears, too slow for the eyes. It's not empty, either. There is presence here, a quiet weight, a gravity of thought, and into this deep calm, A voice once entered. It didn't arrive with thunder or fire. It came in a chair. It came with a soft, synthetic cadence. A voice generated by a machine, but carrying the ideas of a mind that wandered deeper than most dared. A man named Stephen Hawking, with a body that softened, but a mind that sharpened, spoke into this darkness. He asked the cosmos a question no one had dared whisper out loud. If black holes have no way out, how can anything ever escape? He looked at the math. He looked at the sky. And then he found something unexpected. Black holes, it turns out, aren't completely black. They shimmer, not in the way stars shimmer, not invisible light or ultraviolet flash, but in a way that exists just outside of perception. A flicker in quantum space, a breath of energy. This, Hawking discovered, is Hawking radiation. It's faint, it's slow, it's almost nothing, but it's not nothing. That matters, because if a black hole gives off even the tiniest bit of energy, then it changes, it shrinks, it leaks, and over time, over trillions and trillions of years, it will evaporate. Hawking radiation means black holes can die, not with an explosion, not with drama, but with a long, quiet fade, like an ancient echo drifting away into a windless void. You let that image settle. A giant, once terrifying, reduced to a mist of particles subtle, scattered, returning its stolen energy to the cosmos. But where did that energy come from? To answer that, you dripped down smaller, much smaller, into the jittery, humming field of quantum space. Here, the vacuum is not still. It seethes. Pairs of particles pop in and out of existence. One particle, one antiparticle born from borrowed energy, then reabsorbed into the fabric of spacetime. These are virtual particles, and they are everywhere, always. Even in the darkness, beside a black hole. Sometimes, one of these pairs is unlucky or lucky, depending on your perspective. One falls into the black hole, the other escapes. The one that escapes becomes real. It takes energy with it. That's Hawking radiation. But now the black hole has slightly less energy, slightly less mass. This is how it shrinks. It's a paradox in motion. Something escapes from a place where nothing should, a soft rebellion against total silence. Hawking's theory sent ripples through physics. It wasn't just about black holes anymore. It was about information. 'Cause if a black hole evaporates, it eventually disappears. What happens to all the matter and memory it once held? Where is the echo of the planet it swallowed? The astronaut. The poem. If all that vanishes without a trace, the laws of quantum mechanics unravel. Conservation of information, the sacred rule that says no story is ever truly lost, would be broken. So Hawking, with his whisper of radiation, accidentally birthed the black hole information paradox. It wasn't just a physics puzzle. It was a philosophical storm. What is reality if memory can be deleted? What is the universe if it forgets? You feel the tension, now luckened and strange. A dying black hole that shines as it fades. A whisper that both solves and deepens a mystery. Hawking spent decades trying to resolve it. Others joined him. Physicists drew diagrams on chalkboards until their hands cramped. Some believed the information was encoded in the Hawking radiation itself, hidden in the fine entanglements between particles. Others said, no, it's on the event horizon. It's like a movie projected onto the outer shell. And some, just a few suggested, felt maybe black holes don't erase information at all. They just move it somewhere else. Somewhere we can't see. Somewhere outside time. Somewhere that memory rests until we learn how to read gravity like a book. But that idea would come later. For now, Hawking's whisper is enough. You pictured it? A black hole, ancient and slow, glowing softly like a coal at the end of the universe. Not violent, not cruel, just decaying, not destruction, just entropy. That idea that everything ends but slowly, and with a trace comforts you. It's not the violence of an ending that matters, but the story that leads to it. And Hawking's story was as much about life as it was about death. You imagine him curled in his chair, eyes wide behind glasses, a screen flickering with code as his words formed letter by letter. He wasn't afraid of the black hole. He became its translator. He gave it a voice, a radiation, a glow, a whisper. He said, "Look closer. There is more here than silence." And so you do. You lean into the thought, what if black holes are not the end of knowledge, but a deeper beginning? What if they encode not just data, but meaning? Dome, random at first glance, might be entangled with the particles that fell in, attained. That would mean the information isn't lost, it's just disguised, hidden in correlations, folded like origami into the quantum foam. To decode that, we'd need a theory that merges quantum mechanics and gravity, a theory we don't have. Not yet, but we're close. String theory, loop, quantum gravity, the holographic principle. Each theory tries to map the silence Hawking pointed to. Each one searches for the same thing, a way to listen better. To listen, not just to stars, but to voids. Not just to presence, but to absence. You realize now that science, at its best, is not a set of answers. It's a way of paying attention, a meditation, a practice of noticing the faintest shifts in the dark. Hawking noticed what others dismissed, the ghost light of black holes, and because of him, the darkest thing in the cosmos now glows, very slowly, very gently, very faintly. But glow, it does. Now the paradox remains, but in better hands. It's no longer a problem. It's a poem, a riddle, wrapped in radiation. In you, you carry that glow with you now. You are made of particles that might one day fall into a black hole. You are made of thoughts that wonder what will happen next. You are made of questions and whispers and listening. So when you next gaze at the night sky, find the black patch, the place where stars bend around in absence. And know this, even there, thing speaks. Even there, a voice continues to hum. Not gone, not erased. It's quieter than we ever imagined. And as you float once more in the silence, now the puzzle begins to surface. A question that Hawking left for others to chase. If the radiation carries the information, what shape does it take? The answer, some believe, may lie not in the black hole itself, but in its edge, a surface, a screen, a strange kind of map, a hologram, perhaps, where memory is printed in light. That's where your journey goes next, okay? To the shimmer at the border of the void. You return now to the edge, not a cliff, not a wall, but the event horizon, the soft boundary that wraps a black hole like a veil of silence. It is a line drawn, not in color, but in consequence. Once crossed, all paths bend inward. Time itself tilts, falling alongside you, but you are not falling. Not now. You are thinking. You are thinking about what lies beyond this invisible surface, and what secrets might dwell in its stillness. And here, the paradox begins. The black hole information paradox is not loud. It does not cry for your attention, but it waits. It waits in the heart of physics like a folded note no one dares to unfold. You recall the basic truth, the laws of quantum mechanics, those intricate rules that shape atoms, particles. Even your thoughts declare that information cannot be destroyed. The universe is not a careless author. It never loses a page. Every particle has a history. Every action leaves an echo. But now picture a star, a massive star. It collapses. It shrinks past its own ability to hold itself up. And in doing so, it forms a black hole, a region so curved by gravity that not even light can escape. Over time, it consumes matter, light, perhaps even thoughts, a planet, a poem, a memory, gone, eventually, Slowly, the black hole itself evaporates. Its Hawking radiation fades into nothing. And then, silence. But wait, if the black hole disappears and nothing remains, what happened to the information inside? Where is the blueprint of the star? Where is the echo of the astronaut? Where is the whisper of the poem? Now, the paradox stands tall. If the information is truly lost, the foundational laws of physics fracture. Quantum theory collapses. Causality. What leads to what becomes blurry? The story can vanish completely. Then prediction dies. Memory dies. But if the information isn't lost, then where is it? You sit with both sides. You hold them gently. The black hole destroys information. The black hole stores information. Both cannot be true. And yet, both must be. This tension is not a flaw. It is a clue. Physicists have spent decades within this puzzle. Some say the information is destroyed. We must rewrite the rules of quantum mechanics to accept it. Others say the information survives hidden somehow, perhaps encoded in Hawking radiation, perhaps suspended on the event horizon. Still others suggest the answer lies deeper still than the marriage of gravity and quantum mechanics, a theory not yet complete. You drift now toward the core. Not physically, you cannot go there, but with thought, with imagination. Inside the event horizon, the math changes. Space and time swap roles. Singularity awaits the point where the laws you trust begin to fall apart. Some see the singularity as a point of infinite density. Others see it as a veil, a mirror, a metaphor, but everyone agrees it is unknowable, at least for now. And so the paradox sharpens. Imagine someone drops a diary into a black hole. The pages are sucked past the horizon. The ink, the paper, the thoughts gone. Hawking radiation begins. The black hole shrinks. It glows faintly, but the glow seems random. No trace of the diary's words, no echo of its meaning. If that's true, the universe forgets. But what if the radiation is not random? What if, hidden in the quantum entanglement of the particles it emits, the diary still exists, scrambled, encoded, scattered like stardust? Then the black hole becomes a memory machine. Then the laws hold firm, but no one has yet proven it. Some believe in black hole complementarity, a theory that says information can be both inside the black hole and at its surface, depending on how you look. Like the horizon is a hologram of everything that fell in. Others suggest a more radical idea, that the interior of the black hole doesn't exist at all, that all of it to fall, the center. The end is an illusion painted onto the edge. That's the holographic principle, and it leads to its own paradox. Because if everything you are, your body, your thoughts, your actions, can be encoded on a surface, then maybe the universe itself is a projection, a three-dimensional dreamcast from a two-dimensional truth. The paradox expands. It stops being just about black holes. It becomes about you. What is real? Is it the thing or the shadow? Is it the space or the surface? Is it the core or the code? You think of your own memory now. How do you store it? Not in one place, not in a single neuron. Your memories are distributed across patterns, across pathways, across networks of electrical whispers. Maybe the universe stores memory that way too. Not in location, but in relation. Not in place, but in pattern. You close your eyes though. They were already closed in. Picture the black hole again. It pulses softly. It shines faintly. It does not speak, but it listens. Perhaps it remembers, not as we do, but in its own way. You think of Stephen Hawking again, of how he said the black hole isn't black, that it has a temperature, a glow, a story, and now other voices join his. Physicists working in deep time, in dark labs, on whiteboards filled with swirls and sigils of meaning. They look for the resolution to the paradox, not to end it, but to understand it. Some study quantum entanglement, the way two particles, once linked, continue to echo each other, even across light years. Could this be the bridge? Could the information be shared across the horizon, like a secret past between friends? Some examine ADS, CFT correspondence. It's a mouthful that means what happens in a volume might be fully described by its boundary. A hologram, again. We spur, wrapped in gravity. Still others propose firewalls and an abrupt, violent end for anything crossing the event horizon. No slow drift, no gentle fall, just a burn. A contradiction to everything we once thought. And yet, I've never seen a firewall. I've never seen inside. We have only questions and glow. You breathe in, not to solve, but to stay. The paradox is not a failure. It is a promise that something deeper waits, that our understanding still unfolding. And you are part of that unfolding, because you, too, are made of questions. You, too, are a paradox. Your body is matter, but your thoughts are patterns. Your identity is stored in chemistry, but your story is something else. Where do you go when you sleep? Where do you go when you forget? Perhaps the black hole is asking the same. Perhaps the black hole is you, magnified, a vessel, a mystery, a keeper of something precious. You are not afraid, because the paradox, though unresolved, is beautiful. It reminds you that truth is not always simple, that memory is not always linear, that some riddles are worth keeping, and that brings you gently to the next edge. Because if information is preserved, if memory is stored on the horizon, then maybe that surface holds more than we realize. Not just data, but a map, a pattern, a picture of the universe projected from its edge, a hologram. And that's where we go next, to the strange idea that what you see might be a shadow, and what you are might be written on the border, on the border. You lie beneath a vast sky, not the one above your head, but the one inside your mind. A sky drawn not with stars, but with whispers of equations, its quiet shapes that shimmer with meaning. You return to the edge of a black hole, not to fall in, not to flee, but to gently ask it something. Are you storing what I thought you swallowed? The question, like everything near the event horizon, does not echo back. But maybe it doesn't need to. Maybe the answer is already there, painted across the surface. You picture a hologram, not the flickering sci-fi kind, but the real thing, a two-dimensional image, etched with precision, that blooms into three-dimensional form when light touches. It's just right. That is the idea, that the universe sits place of forests and fire, of breath and music, and you might be like that too. What you feel as real, what you see as deep, might only be the echo of something flatter, more fundamental, shining with more truth than form. It sounds like fiction, but it is theory, physics, a calm riddle spoken by black holes. You drift now into that theory. It began not with black holes, but with math, with the strange harmony between certain equations. On one side, a theory of gravity in space, curved and grand and slow. On the other, a theory of fields and particles, quantum and jittery and sharp. And someone noticed, they speak the same language, they describe the same truths, but one lives in a volume, and one lives on a surface. This is the holographic principle. It says, everything that happens in a three-dimensional space could be described by data stored on its boundary. It's like reading an entire novel from a single line of code. It's like watching a life unfold from a thin, silent reel of light. And black holes, they seem to obey this rule. Their entropy, a measure of information, of how much is hidden within, doesn't depend on volume. It depends on surface. That's strange, very strange, because you expect a thing's capacity to grow with its size. But here, In gravity's quietest chamber, the rule is different. The more surface, the more memory. So you begin to wonder, is the black hole truly deep inside? Or is it all on the skin? You imagine a person falling in, okay? Perhaps from far away. Others watch. To them, you slow down. Your body stretches. Your motion freezes. You fade into the horizon. But from your own view, you cross the boundary. Float inward. Feel nothing. Two stories, both true. One from the inside, one from the outside. This is the paradox again. But it softens when you think holographically. Maybe what the outside sees is what's true. Maybe everything your fall, your breath, your thoughts are recorded, encoded, flattened onto that surface, and maybe the inside is just a projection, like a ghost from a shadow, okay? Like death from a pattern. You picture the surface now, not smooth, but pixelated. Tiny grains, each one a unit of area, each one a piece of the story. Scientists call them Planck areas, the smallest square that means anything. On the black hole's horizon, these squares count up like memory cards. Each one holds a bit. Not a bit of you, but a bit of information. Yes or no, light or dark, spin or rest. Together, they form the record, a diary in dust, a book written in silence. What does that mean for the universe? You rise above now, not just above the black hole, but above everything. You float beyond galaxies, beyond clusters, beyond the great web of light. And you ask, could the entire cosmos be a hologram? Could everything you feel, the weight of your body, the sound of rain, the memory of a song, be an echo of something written on a cosmic surface? Could space itself be a stage with no backstage? The idea is not that the world is fake, okay? It's that reality is not where you think it is. The truth may live on the edge. The physicist Leonard Susskind helped shape this view. He said, black holes do not destroy. They encode. They translate falling matter into surface language. A kind of cosmic shorthand, and from that, the idea grew. Not just for black holes, but for everything. Maybe your kitchen, your thoughts, your dreams are all part of a projection from a deeper surface. It doesn't mean less meaning. It means more. Because now, you are part of something written across the cosmos. You are not a speck in a void. You are a note in a song etched into the sky. The math supports it. The logic allows it. But still, no one has touched that surface. No one has held the edge. So for now, it remains a story, a possible truth, a whispered explanation. You do not need to believe it. You only need to rest within it. Let the image settle. A black hole, vast and calm. Its surface shimmering not with fire, but with meaning, and on that surface, the memory of everything it touched. Not erased, not lost, just folded into a pattern you cannot yet read, and now you drift away again. Not backward, not downward, but into something smaller. Because if black holes preserve information, they must do it with particles, with the tiniest flickers of existence. Next, we go there, into the threadbare fabric of space, into the dance of quantum whispers, into the web that holds everything together. Because even a black hole, stitched with something smaller. Close your eyes, breathe in. Now, imagine peeling back the layers of space, as if space itself were a fabric soft black, barely there, and beneath that cloth lies a hum, not loud, not rhythmic, but persistent. This is not the hum of stars or galaxies. Hey, it is the hum of what everything is made of what you are made of. You are about to enter the world of the smallest things. It's a place where certainty dissolves, where time no longer ticks, where the very idea of thing becomes a question. This is the quantum realm, a world not of objects, but of events, not of things sitting still, but of things always becoming. Particles here don't sit at precise addresses. They shimmer between possibilities. They may be here, they may be there. They may be both or neither. And yet, When you reach out gently, so gently, they settle. They show you one face, then vanish again into maybe. This is the place black holes whisper to. This is where they leave their mark. You've heard the big ideas, the warping of space, the bending of time, the swallowing of matter. But underneath that grandeur, something else is happening, something delicate. Information, every photon that fell in, every atom of stardust, is encoded, not just on the surface, but into the very network of quantum fields that form reality. You see, the universe is not just made of particles, it's made of relationships. One particle here can be tied to one over there, miles away, years away, and when one moves, the other knows. This is entanglement, not a metaphor. It's not a feeling, but a measurable fact. It's as if the universe was sewn together with invisible threads, and black holes tug at them. Imagine again the event horizon. That strange veil that marks the edge between outside and in. It looks smooth from a distance, but now you know better. You zoom in, closer, closer still, past atoms, past quarks, down to the foam, the quantum foam, where space itself bubbles and rides. The horizon flickers. Here, it's not a clean line, but a storm of probabilities. And within that storm, information dances. Physicists believe that what falls in your atoms, your data, your light becomes entangled with the particles at the edge. The falling thing doesn't vanish. It becomes a part of the quantum song. Imagine each bit of information weaving its way into the threads. It's not stored in one place, but diffused across a pattern more complex than anything your eyes could trace. And because of entanglement, some of that pattern might stretch outward beyond the black hole, into the universe, you know. So, when a black hole radiates, when it emits that faint glow called Hawking radiation, maybe, just maybe, those tiny emissions carry more than heat. Maybe they carry the memory, the signature, the echo. But here's the twist. The more we learn, the stranger it becomes, because there's a paradox in this entanglement. It goes like this, okay? If the stuff inside the black hole is fully entangled with the stuff on the edge, and that edge also radiates outward, then the outward stuff and the inward stuff can't both be perfectly entangled with the same thing in the quantum world. This causes a problem. It's called the monogamy of entanglement. A particle can't be deeply entangled with two different partners at once. Not fully, not honestly. So what gives? Some say the entanglement breaks, okay? And when it does, a wall of fire appears at the event horizon, a violent contradiction where physics collapses. This is the firewall hypothesis. You'll explore that soon, but not yet. Right now, you're floating in the web itself, a net of trembling threads where black holes are not destroyers, but distorters. You start to wonder, is this the true shape of space? Not a grid, not a void, but a living, vibrating lattice, woven with information, flickering with possibility. Physicists like Juan Maldacena and Leonard Susskind propose something beautiful, that space-time itself might be born from quantum entanglement. That, without these threads, there is no space, no dimension, no here or there. Only when particles are entangled does space stretch between them. It means the geometry you feel, the space between your hand and your chest, the room around you, is not primary. It is emergent, born from connection, born from relationship. This is profound because it means that when you fall into a black hole, what is being altered is not just your location, but the very fabric of relatedness. The threads tug, tangle, tighten, and somehow they hold the story. Black holes, then, are not simple holes. They are knots in the web, massive tangles in the universal threadwork. Their gravity is a symptom of how dense the entanglement has become. So tight, it folds space. So tight, it slows time. And still, it connects. You wonder now, Could your own body be a smaller tangle? Your own consciousness, a pattern of entanglement? There are hints in physics, in neuroscience, ideas that your mind is not a place, but a process, not a thing, but a pattern. So maybe the way black holes store information is not so different from the way you store a memory, not as a file in a drawer, but as a dance across a network. And if that's true, then perhaps your memories don't end at the edges of your skull. Perhaps they ripple into matter, into space, into time, softly, persistently. And perhaps black holes do not destroy memory. They stretch it until it becomes something new, not erased, not lost, just retold in a different language. You return now to the image of a black hole's surface. You imagine it shimmering with tangled quantum threads, each thread a memory of what was, each intersection a relationship, each vibration a story, and the entire surface not still, not flat, but alive with information you cannot read, not yet, but perhaps one day, and perhaps this web, this tangled, intimate net of reality does not end at the horizon. Perhaps it stretches further, outward, to the fire, to the veil, to the question that follows. You're floating again, still held in the hush of thought, still wrapped in the soft, endless fabric of gravity and quantum wonder, your mind. Now, familiar with entanglements, threads, drifts closer to the horizon again, that invisible edge of a black hole where everything changes but nothing announces it. And tonight, you're not just here to watch. You're wondering what happens if you fall in. Not a spaceship, not a stone, but you, gentle, conscious, alive. What do you feel? What do you become? There was once a time when most believed you would feel nothing. That crossing the event horizon would be as gentle as crossing a line, drawn in water, smooth, silent, imperceptible. Einstein's general relativity tells you this. From your own perspective, your time, your space, you would simply float through, no wall, no break, just gravity, deepening around you, stretching space into a quiet funnel, guiding you inward. But then came a whisper, a sharp whisper from the quantum world. It said, no, maybe not. Maybe that edge is not so soft. Maybe it's not a veil, but a wall, a firewall, not a poetic name, but a literal one. A wall of searing energy, of broken entanglements, of physics unraveling itself right at the threshold. You try to imagine it now, approaching the event horizon. You expect stillness, but instead, the very threads of reality snap against your body. They're not threads anymore, they're flames. This idea came from a paradox, a tension between three things that can't all be true. First, that quantum mechanics is right, and information cannot be destroyed. Second, that general relativity is right, and the event horizon is smooth. Third, that if black holes evaporate, their radiation contains all the information of what once fell in. This trinity, these three beliefs cannot live together in peace, so something must give. And the firewall argument says, it's the horizon that breaks, not softly, not quietly, but violently. A curtain of fire erupts at the very edge, burning anything that dares to pass. And so, in this version, you are not gently embraced by gravity. You are incinerated. The moment you touch the horizon, your atoms unspool in a blaze. Your memory evaporates. Your story ends not in silence, but in heat. It's a startling idea, not for how violent it is, but for how it breaks your expectations of what a black hole is supposed to be. You ask, why would this happen? Why would the universe put fire at the doorway to its most silent room? And the answer lies in the threads you met before. If information is truly conserved, if everything that falls in is encoded on the surface, then the entanglement inside must break, and that break creates energy. Not a flicker, not a breath, but an inferno. Yet, it's a quiet rebellion, a counter idea, one that says the horizon might still be soft, in the universe, more graceful than a firewall suggests. This alternative doesn't demand burning. It suggests instead that space can bend the rules without tearing them, that perhaps entanglement is more complex, more braided than we can see. Some physicists believe the paradox can be solved by thinking differently about what the horizon is. Maybe it's not a place at all. Maybe it's a hologram, a projection from a deeper, unseen layer of the universe. In this view, everything that falls in is never really lost. It's just translated into a language we don't yet know. So when you fall in, you feel nothing unusual. No burn, no break, no drama. You simply move deeper, deeper into gravity, deeper into space, deeper into meaning, and the boundary remains gentle, like a breath held in, not a scream let out. Your consciousness might stretch, your time might slow, but there's no pain, no violence, only absorption, only continuation. In this dreamlike vision, the black hole is not a destroyer, but a translator. You become something else, something still made of information, but no longer shaped like you. And though you vanish from sight, your story lingers at the edge, encoded, folded, whispered to the outside world through hawking radiation, or maybe something subtler still. You are not gone. You are rewritten. It is a comforting thought, a poetic counter to the fire. But the truth is, we do not yet know. The debate continues, quietly fierce in academic journals, softly echoing through simulations, waiting for an answer that may take generations to find. And you lie here now, suspended between two visions. One where the black hole is a wall of destruction. One where it is a veil of translation. Both are mathematical. Both are possible. And both say something profound about how the universe handles memory, can change, in passage. Tonight, you are allowed to hold both truths. You can imagine the firewall flaming, fierce, unapologetic. You can imagine the soft, horizon gentle, welcoming, mysterious. And you can choose to let the question remain a question. Let the paradox live as an invitation to wonder, not a puzzle to be solved before sleep. As you drift now, you imagine yourself standing right at the horizon. The light bends around you. Time stretches. Your reflection fades. Behind you is the universe. Stars, planets, silence. Before you is what? A wall, a veil, a dream. You step forward, and in that moment, whatever the truth is, it cradles you, softly, completely. And in this quiet embrace, you begin to wonder, if you passed through the horizon, if you entered the place no one can see, what would you find there? What does it mean to speak of an inside when the inside may be an illusion of the mind? That is where you go next, not to find fire, but to explore what lies beyond every theory. Where maps vanish, but questions remain. You stand at the edge, not a cliff, not a gate, not a barrier made of stone or flame, just space, curving too far for sight to follow. The event horizon is behind you now, but the world you left behind can no longer see where you are. You are inside. But what is inside when no one knows how to draw it? There are no telescopes here, no photographs, no charts pinned to the wall, only ideas, only equations, and dreams. The black hole, as you've learned, is not a tunnel. It is not a passage, nor a portal to elsewhere. It is a collapse of matter, yes, a space, yes, but also of meaning. The further in you go, the less the universe behaves the way it used to. Distances shrink in strange ways. Time tightens like a string being wound. Direction no longer matters. Inward is the only way. The inside of a black hole begins to feel like a thought experiment unfolding inside your chest. Not a place you can visit, but a sensation you can imagine. So you do. You picture it as gently as you can. Imagine that your body keeps falling, your atoms still obeying gravity's endless pull. There are no handholds, no air, no light bouncing off surfaces to show you where the walls might be. There are no walls, only the deep curve of space. It feels like sinking, but not in water. In time, your heartbeat, if it still existed, would stutter. Not from fear, but from physics. Because deep inside the black hole, time does not behave like it once did. If you look outward toward where you came from, you see everything, all of it. It's all at once. The whole future of the universe compressed into a blink. Light rushes to keep up with your descent, but you cannot stop to watch it, because you are falling still, falling not through space, but into gravity itself, toward a point called the singularity, a place where the math breaks, where density becomes infinite, where all the mass that made this black hole, all the stars and dust and planets it swallowed, is squeezed into zero volume, a point that has no surface, no structure, just gravity, so dense it curves everything inward. You try to imagine it, something infinitely small, yet infinitely massive. The singularity is not a thing. It is not a dot glowing at the bottom of a pit. It is an idea pushed to its limit, a whisper in the equations that says, we do not know what happens here, and yet your thoughts keep drifting toward it too. You wonder, if I fell all the way in, what would I see? What would I feel? But here is the quiet truth. No one knows. Not Einstein, not Hawking, not you, and maybe no one ever will, because once something crosses the horizon, its voice falls silent. No light escapes. No signal gets out. No postcard from within. It is as if that part of the universe closes its eyes, and we, on the outside, can only guess what lies beyond the lids. But the guesses are beautiful. Some say the singularity is a point of rebirth, that the collapse might lead not to nothing, but to something else. A bounce, a beginning, not here, not now, but somewhere far away. Another universe, born from the end of this one. A white hole, spitting matter out where this black hole sucked it in. A cosmic mirror. Others say no, that the singularity is the end, final, complete, unreachable, that anything falling in becomes part of the singularity, woven into its infinite density, its timeless depth, a kind of cosmic silence. You sit with these possibilities, one filled with creation, one filled with stillness, and both unknowable, because the laws we use, our physics, our logic, our language, all fall apart in the singularity's shadow. They were built for the outside, for stars and atoms and clocks. Not for this, not for places where distance becomes meaningless and time has no direction. So you're left with wonder. You imagine yourself shrinking now, not your body, okay, but your certainty, shrinking until you are just a thought drifting toward the singularity. You carry questions with you like feathers. Where does space end? Could time fold in on itself? Is there anything smaller than this? And the black hole does not answer. It simply continues being heavy, silent, unfolding itself inward. You remember now what you've heard, that even if the singularity is real, you will never reach it. Not in time, not in body, because, for you, time moves forward, but near the singularity, it moves differently, so strangely that some theories suggest you never quite make it, that you fall forever, never arriving, that your story becomes a limit, approaching the edge of something infinite, but never touching it. And maybe it's the most poetic truth, not that the singularity swallows, but that it waits forever, unreached, unreachable, a horizon within a horizon, a thought that never finishes forming. Still, you want to feel closer, so you imagine the singularity as something more than a point. You imagine it as a memory, the memory of everything that's fallen, INSTARS, gas, light. Perhaps it does not forget. Perhaps it holds everything as compressed truth, not visible, not readable, but present, present in its pull, in its stillness, in its weight, present in the way it changes the shape of space itself. You float there now, between what you can imagine and what can never be known. Not uncomfortable, not lost, just quiet, just curious. You are deep inside something that no one has ever touched, no one has ever seen, but you are not afraid, because this place, though beyond physics, still part of the universe, still a part of everything you've ever loved or wondered about, still governed by laws, even if they're hidden, even if they are whispering just beyond the edge of thought. And from this place, this centerless center, this Maples' interior, you begin to wonder again. If you cannot go further in, is there a way out? Not for you, perhaps, but for information, for meaning, for the history of everything that fell. And that question, that soft, strange question, is what leads you to the next chapter. Because though the inside may be invisible, the outside still glows. And from that glow, from that fading breath of radiation, comes a possibility that black holes do not last forever, that even this infinite weight might one day soften, might one day fade, and from that fading, a message might emerge, a whisper from the dark, a sign that even singularities can sleep, can sleep. They begin with fire, but end in silence. Black holes, those great cosmic sinks, are not eternal. Though they seem infinite in strength, immortal in mystery, they too are part of the universe's rhythm. And every rhythm must slow. You're still there, drifting near that unseen center. You can't feel time in the usual way, not minutes or hours, but stretches of existence longer than stars remember. And yet, time still touches black holes, not all at once, not with violence, but gently, like wind carving a mountain, one grain at a time. You may think black holes only pull, and it's true. Their hunger is vast. They draw in stars, planets, gas, clouds, even light itself. Nothing escapes, not easily. But Stephen Hawking saw deeper, not with eyes, with thought. He imagined the edges of black holes not as barriers, but as bridges between quantum rules and cosmic ones. He asked a question so soft it trembled the pillars of physics. What happens to the smallest flickers of energy right at the edge of a black hole? You see, space isn't empty. Even the vacuum wriggles. Particles come into being for moments, then vanish again, like foam on the surface of a tide. And Hawking saw something peculiar. When one of these particle pairs forms just at the event horizon, one might fall in, and the other might escape. Not often, not brightly, but steadily. This, he said, was Hawking radiation. A black hole, quiet as it seems, emits a whisper, not of sound, of energy. And every bit of that whisper costs the black hole just a little of its mass, just a little. Again, again. The bigger the black hole, the slower this loss. A supermassive black hole at the center of a galaxy might take 100 billion times the age of the universe to truly begin shrinking. But time, in the language of black holes, is vast. Patience is written into their existence. You picture this. Now, a black hole sitting at the heart of a dying galaxy. Stars long gone, its planets cold, its light faded. Still, the black hole spins, pulls, holds space in a knot, and yet, like a breath drawn too long, it starts to release the Hawking. Radiation is tiny, invisible to our eyes, almost unmeasurable. But it is there, a leak in eternity. Slowly, the black hole loses weight, not dramatically, not with flash or fanfare, but like ice evaporating in shadow. And this is how it ends. Not with a roar, but with a fade. The smaller it gets, the faster it shrinks. The radiation strengthens. The leak becomes a flow, And in the final moments, perhaps a spark, a burst of energy, brief and bright, a death rattle, or perhaps a last word. No one has seen this. No telescope has watched it unfold, because it hasn't happened yet, not in this universe. Not that we know, but the math sings it. The equations predict it, and in their song, you find something comforting. Even black holes are not immune to change. It's two time, two endings. They are part of the story, not the punctuation. You might ask, what remains after a black hole dies? Does it leave behind dust, or echo, or memory? No one knows for certain. Some think it leaves only radiation, a final breath, scattered and gone. Others wonder if something survives, a residue, mark in space-time. But perhaps the truth is simpler and more poetic. Perhaps what remains is nothing, not emptiness, not void, just quiet. A stillness so complete it does not ask for anything more. And in that stillness there is peace, because if black holes can end, if even the greatest shadows have their final moment, then the universe is not cruel, it is complete. It gives everything its time, even giants, even silence. You imagine the last black hole, trillions of years from now, fading in a universe grown cold and dark. No stars burn, no galaxies turn. But here, in a corner of space, a flicker, a soft exhale, and then stillness. A black hole's death is not destruction, it is resolution, the closing of a circle, the settling of an old story. You lie with that thought, you, a creature of warmth and light, contemplating a death that takes eons, a death without drama, but not without meaning. It reminds you that time is not the enemy, it is the sculptor. It carves away at everything, but it also gives form. It softens sharpness, it tempers gravity. It carries even black holes toward peace. And in this moment, you understand something quiet and profound, that nothing lasts forever is not a threat. It's a lullaby. The stars will fade, the galaxies will drift, even black holes will let go. And still, in all that fading, there is beauty. You are part of that beauty. Your atoms were born in stars, your breath shaped by gravity, your thoughts dancing between photons. And when you're gone, when you sleep your final sleep, the universe will carry your pattern like it carries everything else. Perhaps someday, in the glow of a dying black hole, a piece of your story will drift free, a whisper, a flicker, a memory folded into the light. And from that light, perhaps a new thought will rise, a question, a theory, a hope, because endings are not walls, they are doorways, and death for a black hole is not ERAS, it is continuation. It's continuation in another form, just as you are, just as everything is. And so, you drift now with that peace in your heart, the peace of knowing that nothing lasts forever, not even darkness. And just beyond that peace, soft curiosity awakens. If black holes die but never let information go, then where does it all go? Where does the memory go? And that question, that beautiful, aching question, leads you gently into the next chapter. You lie very still, not from sleep, but from wonder, because now, after traveling through stars, through spirals of light and shadows of time, a thought arrives that feels strangely personal. What if you, in all your softness, your stories, your choices, what if you are information, not just a body made of dust and breath, but a pattern, a thread in the great weave, a song that continues even when the instrument is gone? This thought floats beside you, soft as mist. It does not intrude. It simply waits. You consider the atoms that make you, hydrogen born in the Big Bang, carbon forged in dying stars, iron from supernova ash dot. You are not just in the universe, you are of it, and each moment you've lived, every joy, every sorrow, every question whispered into darkness adds to the shape of who you are. What if that shape is information? What if the universe remembers it? Not in words, not in photographs, but in the subtle pattern of energy and matter. The way a flame remembers the match that lit it. It's a strange, comforting idea. Physics tells us information cannot be destroyed. Even if the form changes from star to ash, from wave to silence, the underlying structure endures. So, what if you with your dreams and contradictions, your laughter and regrets, could they be encoded in some cosmic language? Not English, not math, something deeper, something like gravity, something like light. When you touch a friend's hand, when you look at the moon, when you love someone quietly across time, do you send ripples that never fade? Do those ripples enter the fabric? Do black holes catch them? You think again of Hawking radiation, of particles escaping from the edge. And the idea that black holes, those great keepers of silence, might not be destroyers, but libraries. Strange. Libraries, dark ones, without aisles or shelves, but filled with pages all the same, pages made not of ink and paper, but of quantum vibrations, subtle shifts in the curve of space-time. Could your memories be pressed into that? Could your sorrows leave imprints? Could your kindness echo in the equations? Physicists once argued, if black holes truly erased what they swallowed, then the laws of physics would unravel, because to lose information is to break the rules of the universe. That's how sacred memory is, not just to poets, but to nature itself. So scientists search for ways to explain how black holes might store what they seem to hide. One idea says everything that falls in leaves a trace at the edge, a kind of cosmic graffiti written on the event horizon. It's called the holographic principle. Imagine you are falling into a black hole. You pass the horizon. To you, it feels like nothing at all, but to an outside observer from the edge, your entire being is smeared across the surface, flattened like a shadow on a screen. That screen might be where your information lives, not lost, just rearranged, not destroyed, just hidden. And one day, when the black hole evaporates, bit by bit, it releases that information back, maybe as light, maybe as vibration, maybe as subtle patterns that shimmer through the void, and maybe, just maybe, a part of you returns, not the you who walks and breathes, but the you made of choices, of thoughts, of memories, and meaning. This is not mysticism. This is science pressed so far into poetry, it begins to rhyme with soul. You breathe, slowly now. You think of the choices you've made today, the ones you regret, the ones that made you proud. They happened, they matter, and in some way, they may be eternal, encoded, not in books, but in the quiet structure of the cosmos. A universe that remembers is a universe that honors not just stars and galaxies, but every story lived within them. So, where does that leave you? Here, still listening, more than atoms, more than a flicker. You are a pattern written in warmth and motion. You are the music a star once sang. You are the question a photon asked when it touched your skin. You are an echo folded carefully into space, and maybe one day, after long stillness, some part of you, some shimmer, some data, some breath of memory, might flicker out from a dying black hole in a distant mind, far in the future, might feel it, not know it, not name it, but feel it like a touch. It's like a sigh, like a whisper that says, I was here, and that is enough to be here. It's wonder, to leave a trace. You think again of falling into a black hole, into love, into sleep. Maybe they are not so different. Each one changes you. Each one asks you to trust what you cannot see. And maybe, just maybe, each one stores a part of you in a place that never forgets. Your eyes drift closed now, not in fear, but in awe, because the universe is not just wide, it is deep, And it does not just expand, it remembers. In the final hush of thought, you feel it. You are not gone. You are folded in. And beyond that fold, just barely beyond, the silence, a question rises. If black holes remember your story, what else might the universe be keeping? You lie inside the quiet now. Not just around you, but within. The hush is not empty. It's full of echoes layered, soft, unhurried. Like a cathedral made of silence. Somewhere in that silence, a memory stirs. But it isn't yours, or rather, it isn't only yours. It belongs to the universe. It begins with light. A photon that once touched your face, with a soft glint of a star that blinked out 1 billion years before you were born. Light, after all, is information. It travels, it carries, it remembers. Every photon that ever left a surface knows something about what it left. That's the quiet truth of physics. Movement is memory. And everything moves. Atoms, thoughts, planets, hearts, the stars above you. Their light doesn't just shine. It tells a story of heat and age, of fusion and fate. It is a letter written across time. And the black holes, those quiet keepers of light, they are the unread parts, the sealed envelopes, not destroyed, waiting. Perhaps when a black hole evaporates, those sealed envelopes open again. The letters drift back out in pieces, in pulses. Some call it Hawking radiation, but you, here in the stillness, you can call it remembrance, because if every piece of the universe carries a trace of what it once was, then nothing is truly lost. Not a voice, not a life, not a moment. You begin to imagine the cosmos not as a void, but as a vast archive, not made of shelves, but of waves, patterns, subtle threads woven into space itself. The stars may not speak, but they write. The planets may not record, but they turn like quiet hands turning pages. In black holes, they are the ink stains, the pauses, the folded corners that mark a place in the universe's autobiography. There's a theory, still young, still whispered in quiet halls of physics. It suggests that the entire universe might be a hologram, that what you see, this vastness, depth, might be the projection of something stored on a distant boundary, a skin, a surface, a cosmic memory card. If this is true, then even you, sitting in your room, lying under stars, breathing into the dark, you are part of the record. Not because of what you do. God, existence itself leaves a trail. Even the things you forget, the half-dreams, the breath you don't notice. It's a tiny warmth between fingers. They're written somewhere into black holes. They're not just endings, they're punctuation. They slow the sentence, curl the meaning, make space for mystery. In their presence, we remember that we do not know everything, and that not knowing can be sacred. Imagine a universe that remembers all your questions, even the ones you never asked aloud. Imagine it folding your wonder into the shape of a spiral galaxy, or into the rhythm of a neutron star's pulse. Somewhere out there, a black hole might be digesting the final breath of a planet, or holding the last photon of a sun that no longer exists, and yet its memory lingers. It affects what comes next. It curves the path of nearby stars. It whispers in the ear of gravity. This is how the universe speaks, not in words, but in motion. A comet's arc, a tide's pull, the wobble of a galaxy's arm. These are not just events. They are replies to something that came before. You, your heartbeat, your stillness, your presence. You are a reply to stardust, to ancestors, to the great silence. And black holes, though they seem so far away, are part of your reply, because they remind you that nothing is wasted, nothing is gone. Not really. A thought released into the air might ripple the molecules. A choice made today might echo in the curvature of time. This is not poetry. Rather, this is science that has wandered so far into truth it becomes indistinguishable from poetry. You float in that idea now, not alone, but surrounded by gravity that remembers, okay? By stars that still shine, okay? By space that listens. And perhaps, as you drift further into rest, okay, you begin to sense that all of this, the falling, the folding, the forgetting, isn't tragic. It's tender. It means that the universe is not careless. It is careful. It keeps everything curates. Somewhere, the light from the first sunrise still lingers. Somewhere, the energy of your first laugh still swirls. Somewhere, the shape of your life has been tucked gently into the story of space itself. So, sleep now, not because the journey is over, but because the story continues. Even when your eyes close, the universe is still writing, and in the ink of gravity, in the margins of time, your name is part of the script. You are not forgotten. You are folded in, and somewhere in the hush of a black hole, or in the quiet turn of a galaxy, the universe is still remembering you.